Hello dear students, our today's lecture is continuation of our previous lecture of Igneous Petrography. In previous lecture of Igneous Petrography, we have discussed the two parameters that affect the texture of igneous rocks. One parameter was crystallinity while another was granularity. Today we are going to discuss the third parameter that affects or the third factor that affects the texture of the igneous rock. Third factor or third parameter is shape of crystals. Shape of crystal is fundamental fabric characteristic. It is important in determining fabric or pattern of a rock. It is actually growth of crystal faces. Shape of crystal refers to the growth of crystal faces. And as we have discussed in our previous lecture that fabric is affected by two major factors. One is the shape of crystal while another is mutual arrangement of the crystal. So shape of crystal is the fundamental or it is basic fabric characteristics, and it is important in determining or affecting the fabric or pattern of rock. Now, what are the crystal forms or types of crystal on the basis of development of their faces? Crystals are divided into three main classes on the basis of development of their faces. One is euhedral crystals. Euhedral crystals are those crystals whose crystal faces are well developed. Euhedral crystal form during the early stages of crystallization, while subhedral crystal refers to that crystal which have partially developed crystal faces. They are characterized by the partially developed crystal faces, and subhedral crystals show or they form during the intermediate stage of crystallization, while anhedral crystal refers to those crystals whose crystal faces are absent. They don't have any well-developed crystal faces, and crystal faces of anhedral crystal are present. They form during the later stages of crystallization. These are some of the macroscopic pictures which show the various mineral crystal shapes or mineral grain shapes. The left one picture shows the euhedral mineral crystals or euhedral mineral grains. You can observe that they have well-developed crystal faces, while on another hand, the subhedral crystals have not well-developed crystal faces, while anhedral crystals have no particular crystal faces. The crystal faces of anhedral crystal are absent. You can observe here that these crystals are irregular in shape. They don't have any particular crystal faces. So such crystals are then termed as anhedral crystals. Now, what are the crystal forms or shapes with respect to relative growth in the three direction of space? Crystal shapes or crystal forms may also be described with respect to the relative growth in the three direction of space. There are four such categories of crystal. First is equidimensional crystal. Equidimensional crystal refers to those crystals which is more or less equally developed in every direction. Any crystal that is more or less equally developed in every direction, then such crystal is termed as equidimensional crystal. Usually polyhedral crystals such as those of agate, leucite and garnet minerals are equidimensional crystals. Tabular crystals. These are those crystals which are better developed or which are well developed in two spatial directions than in the third direction. Tabular crystals usually form plates, tablets, flakes or scales. And tabular crystals are common in the mica and some feldspar minerals. Prismatic crystals. Prismatic crystals are those crystals which are better developed in one direction than in the other two. They are well developed in one direction while as compared to their development in other two directions. Prismatic crystals usually form columns, prisms, rod and needle. Hornblende and apatite are two of the minerals which are characterized by the prismatic crystals. Irregular crystals. Irregular crystals have no development in any direction. They are irregular in shape or irregular in form. Now, our now we are going to discuss the fourth category of or fourth parameter that affect the texture of igneous rocks. And this parameter or this factor is mutual arrangement or mutual relations of crystals or mutual arrangement of crystals and glassy matter. We have discussed that along with the shape, mutual arrangement or relationship of grains also affect the fabric. Textures that depend on mutual relations of grains may be classified as follows. First category of texture is equigranular texture, while another category is inequigranular texture. Equigranular texture, it refers to that type of texture in which constituent minerals are all of approximately the same size. The mineral present within such texture or within such rock are all of approximately the same size means that all mineral constituents or all minerals present within the rock are of almost the same size, and such rocks characterized by the equigranular texture has an evenly or has uniform granular aspect both in hand specimen and in the thin section. You can observe here this is macroscopic view of granular texture, and you can observe that all the minerals are almost same size. They are all of approximately the same size. Another category or another class is inequigranular texture. Inequigranular texture refers to that texture when the size of constituent minerals of an igneous rock greatly varies. Means that constituent minerals are of various sizes. They are not characterized by the same size minerals. Such texture is termed as inequigranular texture. Inequigranular texture is then redivided or subdivided into two categories. One is seriate texture while another is bimodular texture. Seriate texture is that type of inequigranular texture in which grains of all sizes are present, while in bimodular texture refers to that inequigranular texture in which generally there are two dominating sizes with few or no crystals of intermediate size. Such texture is then termed as bimodular texture. Now, types of inequigranular texture. First type is porphyritic texture. Porphyritic texture refers to that texture in which large crystals are enveloped or embedded in a fine-grained ground mass. In porphyritic texture, large crystals are present or they are embedded within the fine-grained ground mass, and the large crystals which are present in the porphyritic texture are termed as phenocryst, while the fine grains are called, or fine-grained minerals are called as ground mass. Porphyritic texture is common in hypabasal rocks such as dikes and sills. Hypabasal rocks commonly occur in the form of dikes and sills, and porphyritic texture also occur in the volcanic rocks. The rock that is characterized by the porphyritic texture is termed as ferric rock, while rock that lacks porphyritic texture is termed as aferric rock. Now, how porphyritic texture form? First, we observe these pictures. These microscopic pictures are showing the porphyritic texture. These are the porphyritic rocks, or we can say that these are ferric rocks. These are the larger crystals of which are of plagioclase. These are phenocryst, while the fine-grained mass is the ground mass. So such texture in which large grains are present within the fine-grained ground mass is termed as porphyritic texture. Now, how does porphyritic texture form? This texture forms due to abrupt changes in physical condition during solidification of magma. Slow cooling favors the formation of phenocryst, or we can say that slow cooling results in the phenocryst, while rapid cooling results in the formation of ground mass. Now, types of porphyritic texture on the basis of visibility. First is mega porphyritic texture. It refers to that type of porphyritic texture which is visible or which can be distinguished with the naked eyes, and there is no need of magnification with the microscope. While microporphyritic texture refers to that porphyritic texture that is only visible with the use of microscope. Now, types on the basis of ground mass, whether the ground mass is glass or it is cryptocrystalline in nature. When the ground mass in porphyritic texture is glass, then such porphyritic texture is termed as vitrophyric, or such rock is then called as vitrophyric rock. While a rock having porphyritic texture in which ground mass is cryptocrystalline, then such rock is termed as felsopheric rock. Glomeroporphyritic or cumulophilic texture, when the phenocrysts are in the form of clusters of grains, then such porphyritic texture is termed as glomeroporphyritic texture or cumulophilic texture. Whenever phenocrysts occur in the form of clusters or in the form of grains, they are not scattered, then such porphyritic texture is termed as glomerophilic texture or cumulophilic texture. Poikiliotic texture. Poikiliotic texture is opposite of porphyritic texture. In this texture, smaller crystals are enclosed or they are enveloped in larger crystals without common orientation. In the porphyritic texture, we have discussed that larger crystals are enclosed or they are embedded in the smaller crystals, while in poikiliotic texture, smaller crystals are enclosed in the larger ones. Now, the smaller crystals which are enclosed are termed as oikocryst, while the enclosing crystals are the larger crystals which envelop or which enclose the smaller crystals are termed as cryst. Now, how poikiliotic texture forms? Poikiliotic texture, the formation of poikiliotic texture is complex and difficult to explain. However, for the formation of poikiliotic texture, one constituent must be present in relatively large amount than the number of their other constituents which are present in the small amount. And this constituent which is present in relatively large amount must be lost to crystallize so that it grows to the larger size. The poikiliotic texture indicates that enclosed minerals cease crystallization at an earlier stage than the surrounding minerals. It means that the oikocrysts have stopped the crystallization earlier than the cryst or the cryst. This is the microscopic image showing the poikiliotic texture. These are the oikocrysts, while the larger crystals are the cryst. Third texture is the Ophitic texture. It is special type of poikiliotic texture in which large subhedral grains plates of agate completely enclose or surround numerous thin layers of plagioclase. What is Ophitic texture? It is special type of poikiliotic texture in which large subhedral grains or plates of agate completely surround or enclose numerous thin layers of plagioclase. These black layers, thin layers represent the plagioclase and they are surrounded by the subhedral grains of the agate. Agate is pyroxene. Ophitic texture is characteristic texture of rocks called as dolerite. This texture occurs within the dolerite rock. Subophitic texture. When agates are not well developed, that is, they are not large enough to enclose the layers of plagioclase completely, then such texture is termed as subophatic texture. Now, how the ophitic texture develops? This texture shows simultaneous crystallization of plagioclase and pyroxene, and it develops because of difference in the crystallization properties of two minerals. The both minerals are crystallized simultaneously. Both minerals means that plagioclase and pyroxene refers to the agate. So both plagioclase and pyroxene have simultaneously crystallized, but this texture develops due to the difference in the crystallization properties or crystallization features of the two minerals. This texture indicates that the enclosed mineral sees crystallization at an earlier stage than the surrounding mineral. When a late crystallizing mineral completely encloses numerous smaller grains of other minerals, then such texture is Poikiliotic texture. Ophitic texture shows or it indicates that the enclosed mineral which is present inside or it is enclosed have stopped the crystallization earlier than the enclosing or than the surrounding mineral. And whenever the last crystallizing mineral completely encloses or completely surrounds the numerous smaller grains of other minerals, then such texture is termed as Poikiliotic texture. Our fourth category of texture is intergranular or intercertal texture. This is common in mafic rocks such as basalt. In most basalts, layers or tablets of plagioclase are arranged in such manner that various triangular or polygonal interspaces are left between the crystals. In most mafic rocks, mostly in basalt, layers of plagioclase are arranged in such a way that various triangular or polygonal interspaces are left between the crystals. Now, if these interspaces that have been formed or that have been left due to the arrangement of layers or tablets of plagioclase, if these interspaces are filled with the olivine, pyroxene, or iron oxide, then such texture is termed as intergranular texture. And intergranular texture is possessed by the hypobasal and the volcanic rock. While what is intercertal texture? Intercertal texture refers to the texture when the interspaces are filled with the substance other than olivine, pyroxene, or iron oxide, then such texture is termed as intercertal texture. Usually in intercertal texture, the infilling substance is glass or other secondary minerals such as serpentine and mica. Acidic igneous rocks have intercertal texture. So if the interspaces are filled with the olivine, pyroxene, or iron oxide, then such texture is intergranular texture. However, when the interspaces are filled with the glass or other secondary minerals such as serpentine and mica, then such texture is intercertal texture. These are the intergranular texture. These are the images showing the intergranular texture, while this indicates the subophatic texture. The pyroxene doesn't surround the layers of plagioclase completely, while in ophitic texture, the pyroxene completely surrounds the layers of plagioclase.